Let's take a look at an example problem from Module 11.1 for ME270 Structural Dynamics. So in this problem here, we're given a 3 degree of freedom spring mass system. So two parts to this problem. The first part, they're telling us for the system shown below, they want us to determine the values of our omega squared for an R value of 1, 2, and 3. They also want us to sketch the characteristic polynomial for omega values here from 0 to 2.0. Now in part B of the problem, they asked us to solve for the mode shape with the corresponding omega 2. So we see here is our system right here. Here's the 3 degree of freedom spring mass system. So you can see we have 3 carts, each with a mass equal to 1. You can see we have 4 springs here, k equals 1, k equals 1, k equals 1, and k equals 1. And we have 3 displacements here, u1, u2, and u3. Now they give us our determinant down here, our matrix for our spring k, where we have our values here, 2, -1, 0, -1, 2, -1, 0, -1, and 2. And they give us our mass matrix over here, 1, 0, 0, 0, 1, 0, and 0, 0, 1. So with the information that we have there, we can create our setup page. So on our setup page here, name of our problem, example 10.1 here, we're given our R values for 1, 2, and 3. We're given our omega going from 0 to 2. We're given our initial diagram that we drew out here. Those are 3 masses, our 4 springs, our 3 distances. And we have our K matrix and our M matrix right there. And what we're looking to solve for is our omega squared terms for R equals 1, 2, and 3. And for part B, we're looking for our mode shapes. So before we get our solution for this problem here, the first thing that we want to do is we want to figure out what our key equations are. So our key equations in this problem is our dynamics matrix. So we can see this is a relationship here. D of omega r is equal to k minus our omega r squared times m. And this comes from equation 10.12 in our textbook. So we can see down here below, I've taken the excerpt from our textbook here, and this is our equation 10.12 right here, where we draw that from. So we can reference back to that for further details of how to plug in and what each of the variables are within this governing equation. So as now we begin our solution, we have our setup page, we have a problem statement, and we now have our governing equation. So we can reference back to those at any point as we're going through the solution. So for our solution here, we take our governing equation again from 10.12 in our textbook. We have d of omega r is equal to k minus our omega r squared times m, where we're given in the problem statement our matrix for k and our matrix for m. So we can plug this in for our k there and for our m there, and now we get to do some matrix math. So the first thing we do is we plug in, here's our k matrix, here's our m matrix, then we have our omega squared, sorry, omega sub r squared right there, omega sub r squared, and then d of omega r right there. So we plug into that there, and I look at this relationship and say, okay, I see this omega r squared here. I'm going to distribute this through my m matrix. So that's what I do down here. Leave my k matrix the same over here, and now I distribute through my omega r squared. So I end up with omega r squared 0, 0, 0, omega r squared 0, 0, 0, omega r squared. So at that point there, now I have 2 matrices of the same size. They're both 3 by 3 matrices here. So now I can just do some subtraction. It'll be 2 minus my omega r squared. -1 minus 0, 0 minus 0. Then down to the next row, -1 minus 0, 2 minus my omega r squared, -1 minus 0, 0 minus 0, -1 minus 0, and 2 minus omega r squared. So that is exactly how I come up with this matrix right here. So now that we have the new 3 by 3 matrix after doing our subtraction, we want to take the determinant. So I'm going to take a little sidebar here and recall how we do some matricing math here. So recall if we have a 3 by 3 matrix, A, B, C, D, E, F, G, H, and I here, just for simplicity's sake so we can see where everything goes. We can take the top row, my A, my B, and my C here, and you can see I've color coordinated this. So there's my A, my B, and my C right here. Put those through, so it's A, this guy right here now, times this matrix, E, F, H, and I. Then it's B right here times D, F, G, and I. And then it's C times my D, E, G, and H. So that forms this relationship down here. So now that we've gone through and reviewed the matrixy math for this, the next step is to actually do it for our particular problem here. So I'm going to color coordinate it the same way. There's my A, there's my B, there's my C for all this. So we follow this same format over here. We end up with, when we take the determinant of our matrix D of omega r, we end up with this relationship here. D of omega r is equal to our A value, which is 2 minus omega squared, times this part of our matrix down here. Boom, boom, there and there. So this is 2 minus I omega r minus 1, 2 minus omega squared again. So now this is minus, right there, minus times our b. So it's a double negative, minus a negative 1 from that there, times now the 2 outside, this here and this here. So negative 1, 0, 2 minus omega r squared. Plus now we have 0 times our left-hand side of the matrix over here, our negative 1, 2 minus omega r squared, 0 minus 1. But this whole term is going to end up going to 0 because we're multiplying through by this 0 here. So that reduces and simplifies down. What we end up with for our determinant of this matrix is we get this final answer down here. So doing that out did give us an answer for our determinant of our matrix, D of omega here. But what we also saw with this now is that we can reduce this down a little bit further. We can multiply through by our 2 minus omega squared here and by our 1 here to simplify this down a little bit more and do our math a little bit further. So once we simplify this down, what we end up with is our determinant for our D of omega matrix right here is equal to, when we do out the math now, 2 minus omega squared times omega to the fourth minus 4 omega squared plus 2. So just a little bit more in-depth matrix math here to get us down to this step here. What we really want now is to solve this for omega squared. So if we want omega squared out of this, there's a couple different things we can do. We can do, first thing we need to do is multiply this by this here, which is a binomial by a trinomial. So there's a couple different ways you can do this. Plug this in a numeric solver. I'm going to show you a quick step to do it by hand. So step 1 here, if we're going to solve this out by hand for binomial times a trinomial, we can distribute through all of this here. So we're taking this 2 value here, distributing through our right-hand side, our trinomial over here. We multiply that all by 2. We end up with 2 omegas to the fourth minus 8 omega squared plus 4. And then the next step, step 2, is to distribute the next part of that, our negative omega squared. So this guy right here, through all of our right-hand side, our trinomial over here. So we multiply that by through, and we end up with negative omega to the 6th plus 4 omega to the 4th minus 2 omega squared there. So then we can combine our like terms when we put these two together, add them together, and we end up with a negative omega to the 6th plus 4 omega to the 4th plus 2 omega to the 4th minus 2 omega squared minus 8 omega squared plus 4. We can reduce this down, combine like terms here. We end up with negative omega to the 6th plus 6 omega to the 4th. When we combine our 4 omega to the 4th and 2 omega to the 4th, there becomes 6. Then we can combine our omega squareds here to get a negative 10 omega squared plus a 4 there. And from this here, then we can solve it for omega 1, omega 2, omega 3. Now, again, you can plug this right into a solver online. You can plug it into MATLAB, Python, any type of numeric solver you want. Your calculator can even solve this, and even Excel can solve something like this. So we end up with this here. We have omega 1 squared is equal to 2 minus the square root of 2. Omega 2 squared is equal to 2. And omega 3 squared is equal to 2 plus the square root of 2.